Hello everyone, today we will see the topic 12 buckling load in ANSYS Workbench. So introduction. Static loads too can produce instabilities given the particular combination of geometry and loading. Buckling of a long slender bar in axial compression is a common example. ANSYS simulation provides tools for computing buckling estimates of elastic structures. We start by considering two problems that can radially be checked, a fixed free column and a pin column. So this is the problem statement for today's session. We are going to cover in a practical way on the software. Drag and drop the project, give name to it, buckling load. Now we are setting the material as a structural steel for the project. Now we have to create the geometry. Now we are creating a geometry of bar, long axial bar. For that we have to create the circle and we have to give dimensions to it. It should be 10 meter. Now we can extrude this and the length is, extrusion length is 50 meter. Click on generate. Now we have to create a one plane from face. Select the face, click on apply, click on generate. So it have created the one plane. So click on plane and click on sketch. Now we'll give the dimensions to it, 5 meter. Now we are gonna extrude this sketch, 50 meter, click on apply and then click on generate. So this is our geometry for today's session. So here we are editing this to 30 meter and then click on generate. Okay, so this is a geometry. Now double click on model setup. First of all we will check for the material. It should be structural steel. Now we are going to mesh it, click on generate mesh. So the default mesh is generated. Now we are going to apply the conditions. So I am going to apply first fixed support on this face, click on apply and the force on this face, click on apply, magnitude of 1000 Newton. I am going to apply one more force here on this face, click on apply, magnitude of 2000 Newton. So I am going to change the direction into outward direction, click on apply. Now in the solution, click on total deformation and click on solve. So solution is generated. So this is how you can see the total deformation of an bar. We'll see in an animated way. Now there is a one more option that we can see here. For the buckling load, we are going to add the eigenvalue buckling into the solution. So we have connected the eigenvalue buckling to the solution. Now just double click on setup. So now this is, here you can see the solutions of the earlier buckling load. Here we have to add the eigenvalue buckling. In the analysis setting, The same way we have to find the modes that we have done earlier in the frequency analysis. Here you can change the maximum number of modes that we have to find. I am giving 2 as a default modes to find. Now in the solution, click on solve. Now solution is generated. Here you can see for the mode 1 the data is minus 7.6176 e raised to 006. This is the load multiplier for the mode 1 and the mode 2. Now we have to convert this load multiplier into the deformation of each individual. Right click on it and click on create mode shape results. Now here you can see the total deformation of both the modes has been added. Now just click on solve. Now here you can see the animation of the first deformation. This is how it is going to buckle. Now for the second deformation, the maximum and the minimum values are shown here. For the second deformation, the maximum value is 1.0324 and minimum value is 0. This is how we can do the buckling load as well as the eigenvalue buckling.